These are the Chapter 1, Note 6 on standard deviation. Today we're going to talk about the definition for standard deviation. We will learn a formula for calculating standard deviation. We'll also use your calculator to find it. And we'll talk informally how you can usually use like a graph to kind of informally talk about what standard deviation is. There is a definition that you will need to know for standard deviation. I have seen it on past AP exams. And the definition goes something like this. The standard deviation is a typical distance between the individual data points and the mean. The phrase a typical distance may sound a little vague. It doesn't say an average distance. It just says a typical distance. So there is some kind of wiggle room, I guess, in the definition itself. Because it might be a little difficult to remember it, I have a special guest artist here to maybe provide you with some alternative way of remembering this definition. So here we go. A typical distance between the individual data points and the mean, that is the standard deviation. A typical distance between the individual data points and the mean, that is the standard deviation. Okay, that was uncomfortable. Anyway, the standard deviation formula you see on your paper right here is one that you do not have to memorize for the test. In fact, you're going to be using the standard deviation formula twice in this class. One is going to be on the problem we're just about to do, and the other time will be on one problem on your homework, which will be part of your next homework check. So make sure you do 141 Part A using the method we're going to show here. Otherwise, you'll be able to use your calculator's 1var stats command to identify the standard deviation from really this point forward, which is this SX command that we talked about earlier last week. So to calculate standard deviation using a formula, we're going to use this formula here, and we need to start with some data. So we're going to enter in some data and calculate the standard deviation. I thought some data we could use would be going to my YouTube channel and picking out the 4 most popular views as of yesterday. We have 184 views, 176, 173, and 159, and we will use that data in our work here. So let me put the screen back here. The data points again were 184, 176, 173, and 159. And our first step is to take the average of these numbers. Or actually, that's our second step, is to take the average of these numbers, which says find the mean x bar of the data points. We'll write this number at the bottom of the column. Do not round this value. So if you did get a decimal for this value, I would have you use all the decimal places. However, in this scenario, when you actually add these 4 numbers and divide that by 3, you'll get something that's nice and pretty to work with. If you didn't, you would use the big long decimal you get. In this case, we have something nice. It's 173. That's x bar, the mean of our sample data. Step 3, it says in the second column, we're going to take each data value and subtract the mean. These are the deviations from the mean. And you'll notice that's denoted by x bar sub 1 minus x bar. That is part of our standard deviation formula that you kind of see right here. So we're going to subtract each of these numbers from the mean to calculate what's called the deviation. We're going to subtract these numbers so that this value, the x sub I value, is always listed first. It will potentially mean that we may get some negative numbers when we subtract these values. I would suspect you can do a lot of the subtraction in your head. 184 minus 73, 176 minus 73, 173 minus itself, and 159 minus 173 should be negative 14. In step 4, we're going to find the sum of these deviations and write this sum at the bottom of the second column. So we're going to take 11, 3, 0, and negative 14 and add these numbers together. And if you've done this step correctly, you should notice that what you always get is this value, 0. The deviations from the mean, we should have equal representation in both the positive and negative directions. So we should get a 0 here. Step 5, in the third column, take each deviation from the second column and square it. Do not round these values. So again, if we had decimal values, you would not round them. The important thing here is that we are not rounding anything at this point. Remember, when you do negative 14 and square it, make sure you put it inside parentheses. So our deviation squared should be 121, 9, 0, and 196. The numbers in this column will always be positive or 0, which means that your deviation squared sum could possibly be 0 if all these numbers are 0. Otherwise, you should get a positive value here. And in this case, when you add these numbers together, the answer you get is 326, which we will put here. This is the sum. In step 6, if you had decimal numbers here, again, we would not want to round this. Now what we can do is we can actually substitute values into the standard deviation formula. Standard deviation is equal to the square root of 1 over n minus 1. N is the number of data points we have. We had 4 data points we were working with. This value, the sum we just calculated, was each value minus the mean squared, and we took the sum of them. So this 326 goes right here. When we calculate this, we can do the square root. I'm going to put another set of parentheses here for the 1 over 4 minus 1, which is 1 over 3. And then we're going to multiply this by 326. Close off the parentheses again, hit enter. And the standard deviation I got was about 10.4. Now it says in step 8 to check your answer using a calculator. Remember, we can enter our numbers in our calculator by hitting Stat Edit. We can put the numbers in right here. And then we can go Stat, Calc, 1 var stats using list 1. And you can see right here, SX, standard deviation, 10.424. That's the same value we got using our calculator or using our formula. What is this number? It's a typical distance between the individual data points and the mean. So as you look at our original data, you can say that most of our data here is within roughly about 10.4 of the mean. Some of the numbers are a little further away from the mean, some are a little bit closer, but it's a typical distance. It is not the average distance. The average distance would mean taking these numbers and dividing by 4, which would be 0 divided by 4. Or even if you took the absolute value of these numbers, let's say you took 11 and 3 and 0, and we made this a positive 14. If we divide this by 4, you'll notice that we don't get this 10.4 number. So you want to make sure that you don't say it's an average distance. We just use the term it's a typical distance. So as we look at the problem at the top of the next page, it says which graph has the largest standard deviation. We want to recall what the definition is for standard deviation again.
A typical distance between the individual data points and the mean, that is the standard deviation.
So as you look at these graphs, you have to ask yourself, in which case are we going to have a bigger typical distance between the individual data points and the mean? So in which case are more of the points further away? Which case do we have a further distance between a majority of the points and the mean? Well, when you compare these graphs, in the first graph we have a lot of points that are close to the mean, but we also have these, they're not even outliers, but we've got a lot of values out here, some tall bars over on each of these sides here that are kind of far away from the mean. Whereas in this case, the tall bars are all close to the mean, so most of the values are right here in the middle, which are close to the mean, compared to a few values on the outside which aren't as close. In both cases, I'd view the mean as kind of being somewhere in this 4 to 5 vicinity. So I'd say the graph that has the larger standard deviation would be this graph on the left, primarily because a majority of the points, kind of this 0 to 1 and the 7 to 8 span, are far away from the mean. They have a bigger distance from the mean than these points in the middle here do. On the normal curve, the numbers at the bottom represent standard deviations away from the mean. The mean of the normal curve is at 0. So if you take this standard normal curve, we usually expect average to be right here in the middle of the curve. You'll see a 0 here. That corresponds with 0 standard deviations from the mean, and that makes sense. If you're on the mean, you're not far away from the mean. The typical distance is 0. As you get further away, you see these tick marks. They're also known as z-scores. So as you get further from the mean, if you're 1, 2, or 3 standard deviations from the mean, you're not as likely to occur. And on a bell curve, they kind of correspond with lower values here. We'll talk more about the standard normal curve later on this year. Armed with this information, again, there'll be one problem on tonight's homework where you're going to have to calculate standard deviation by hand. That's problem 1.41a that will be on your homework check. So you need to solve it kind of using this table method and following the equation that we did right down here. Otherwise, from this point onward, other than that problem, you will be able to always use your calculator to calculate the standard deviation, and again refer to this SX value, that is the standard deviation. So after today's problem 141a, you will always be able to use this, and calculating standard deviation by hand is not a requirement for the AP Stats exam.